All right, here we go. 4.3, greatest common factor. Okay, yesterday y'all did the factor tree. Okay, and listed all the, y'all know how to do factors, y'all learn how to do multiples, you know how to find the prime factors. Okay, so you need to take all of that you learned in the last couple of days and apply it to the greatest common factor. Okay, so for example, GCF, we're going to abbreviate it as GCF, greatest common factor. What it is the largest number that can be divided into the given numbers. Greatest common factor, the largest number that can be divided into the given numbers. Keep in mind, we're talking about, if you look, it's the greatest common factor, right? Greatest, it's the largest. Common. So we're looking for one number, the biggest number, the largest number that can go into, be divided into the given numbers. Now notice it's plural. So we're looking for the largest number that can be divided evenly into 2 or 3 or more specific numbers. Now, example. 12 and 18. Let's list all the factors. Now remember, there's a difference between factors and prime factors. I'm saying, what are all the factors of 12? Let's list them in order. First one's going to be 1. What would the next one be? 2, 3, 4, 6, 12. Those are all the factors that can go into 12 evenly. 5 can't go into that evenly. 9 can't go into that evenly. 10 can't. But all of these numbers can. 1 times what gives you 12? 12. 2, how many times does it go into 12? 6 times. 3 goes into 12 4 times. So if you know 2 goes in there, just ask yourself how many times. That's a factor. Oh, I know 3 goes in there. How many times? 4. Oh, there's another factor. Some of you are leaving 1 or 2 out of your answers. But if you would go back to the factors that you already have down and ask yourself how many times do they go in there, you'll find your other missing factor. Okay, let's list all of the factors of 18, starting with 1. 2,
3, 6, 9, 18.
Okay, now these are all of the factors, not multiples, and they're not prime factors. They are just factors. Now, let's look at which ones we have in common. Remember, we're looking for common factors. We have 1 in common. We have 2 in common. We have 3 in common. And we have 6 in common. The GCF, or greatest common factor, for 12 and 18 is what?
6.
That's right. Well, hurry up and fix it. So 6 is your greatest common factor. It's the largest number that can go into both of those evenly. Do y'all all see that? 2 is a common factor. 3 is a common factor. But 6 is the greatest common factor. Any question? Okay, that seems simple enough, right? Okay, but you know your book isn't going to be as kind as to give you nice little numbers like that where you can just list the factors or think about it and come up with the greatest common factor. They're going to give you numbers that are quite large.
It'd be like Excel.
It's going to be like IXL. It's going to be a little bit more challenging. So, you're going to use prime factorization to find the GCF. Sometimes you can just look at the numbers and you know what it is. Or you can list the factors and figure it out. But there's going to be times when you cannot do that. So you're going to use prime factorization to find that GCF. You know what prime factorization is?
Yeah, so tree.
What?
Factor trees.
Factor tree. We're going to do the factor tree. Step 1. You're going to write the prime factorization for each number. Again, we're talking about the factor tree. I'm actually waving at someone. I'm not just waving at the door.
Tell them time.
I've been waving at you forever.
Well, I was watching my kids pass. Okay. Do you have a bottle?
I do. You need it?
Yeah.
Just need a jug. I'm just kidding.
There's a jug.
It's left, but I definitely leave it with you.
Oh. That's not it.
That was the worst time we on.
Where'd it go?
Wait, what type of bottle?
Alright, come back over.
I can dump this out.
No. Taylor, thank you. What?
Let me go check with Lisa.
Wait. I'm
Oh,
losing
I'm
my mind.
talking about a spray bottle. Yeah, you can
I'm
just
not
dump
talking
it out.
about water bottle.
Holes.
Okay, calm down. Okay. Since I'm recording, I gotta keep going. Step 2. Identify the prime factors that are common to all the given. I could have come to you, by the way. So identify all the prime factors that are common. And I'll show you how to do that. Thank you. Next time I can just come to you. Seriously.
Sure.
Thank you. 3. Find the product
It smells weird in here.
of the common prime factors. What does product mean?
Multiplication.
That's right. Product means multiplication. While you're copying that, I found out why everyone is sneezing and runny nose. It was on the news. Allergies are at the extreme levels right now.
Yeah, I heard that. Why? People are dying from allergies.
Ragweed.
Are there actually people dying from allergies?
I don't know, Taylor.
You should ask her.
But I do know it's not my shampoo or my lotion or anything else.
Or is it?
It is just allergies, so it's not my fault.
Or is it?
Taylor, you're gonna have to go back to your desk if you don't knock it off. Okay, so those are the steps. Let's start with an example. Does everyone have the above down?
Above?
I restarted because this page, I had a staple.
Okay, but where are you? Because I have to keep moving.
I'm watching you. I'm good.
You sure? Okay, so example. Find the GCF of 24 and 36. Find the GCF of 24 and 36. Okay, yes, you could just list all the factors and figure it out, but you need to know how to do the factor tree. You need to know how to do steps 1 through 3. So we're going to start by making the factor trees. What two numbers when multiplied? Give me 24. Gabby? What?
6 times
I can't hear her.
6 times 4.
6 times 4. Okay. 6 times 4. All right. Are these two numbers prime?
No.
Nope. Izzy's shaking her head no. So we're going to continue on with our tree. What two numbers give us 6?
8 on 2.
3 times 2. And 3 is prime and 2 is prime. So I'm circling them. And of course, 2 times 2 gives us 4. And those are prime, so I'm circling them. All right, 36. What two numbers give us 36, Cecilia?
6 times 6.
All right, 6 times 6. Joanne, are those prime?
No.
No. So we're going to keep going. I can do 2 times 3 here, and both of those are prime. And 2 times 3 here, and those are prime. Now, we did step 1 where it says write the prime factorization of each number. Okay? Well, we're not completely there. 24 and 36. So remember, you write them in order from least to greatest. So 2 times, you have to do times because remember it says find the product. Crossing it out, times 2, crossing it out, times 2, crossing it out. And then for 36, I have 2, cross it out, times 2, cross it out, times 3, cross it out, times 3, cross it out. All right. Now, step 2 says identify the prime factors common to all the given numbers. I have a 2 that's common, so I'm circling it. I have another 2 that's common, I'm circling it. And I have a 3 that's common, and I'm circling it. After you've done that, take a look. Make sure you understand what I just did. Yes?
Why would we put since we have more than 1 2 in exponential?
Because we're not doing that yet. We're putting it out like this so we can find all the things that I have in common. Yes?
Why wouldn't we do the 3's that are on top of each other?
You can.
We can?
Yeah. You most certainly could circle those. Now, guys, this right here, what I'm about to show you, is the biggest mistake my students make. With this common set of 2's, you're only going to write down 1, 2. They have a 2 in common. It's not 2 2s, it's 1 2. Times, because this is step 3, find the product. And then times 3. Do you see what I'm doing here?
See.
So I'm taking one of each pair. They have a 2 in common. They have another 2 in common. They have a 3 in common. Now, step 3 says find the product. So what's 2 times 2?
4.
What's 4 times 3? So the GCF is 12.
That's kind of cool.
And that's what you're doing today.
Wait, where was step 3? On the top.
That was the
Product. Product is multiplying right here.
Oh. And then step 2 is just circling.
Mm-hmm. Y'all have this down? Do what? Any questions? You got it?
Yes.
Okay. Let's do another. This time, let's do bigger numbers. Bless you.
Let's see.
180 and 600. The 180 ends in 0. So what number do we know goes into it? 10. So 10 times what gives us 180? 18. Are those prime? Oh, no. So I keep going. What two numbers get when multiplied give me 10?
5 times 5. Or 2. 5 times 2.
5 times 2. And those are prime. What two numbers give me 18?
9 times
2 is prime, but 9 is not. That would be 3 times 3. And those are prime. All right, let's now start at 600. Do you have a question?
No.
Okay. What two numbers, when multiplied, give me 600?
60 and 10.
Okay. Is she right? Okay. $60 times 10. And we know 10 is going to be like 2 times 5. Those are prime. What two numbers give me 60?
10 and 6.
All right, 10 and 6. And then we have another 2 times 5. And your factor trees may look a little bit different. And that's fine, but you're still going to get the same stuff. So make sure you have that. Does everyone have this?
Yes.
Okay, so now we're going to write out our prime factors. For 180, I have, and remember, least to greatest and cross out. 2 times 2 times 3 times 3 times 5. And then for 600, I have 2 times 2 times 2 times 3 times 5 times 5. When you cross it out, it just helps so that you don't accidentally put too many. All right, so now we're going to find all of our common ones. Michael, what should I be circling?
2, the other 2.
This two?
No.
So this pair of twos,
Yeah.
this pair of twos,
And the 3s, 2, 3.
I can do these two threes if I want. What else? And I can do these fives. Now, see my little arrows? I'm going to bring down one number from each of those pairs. Don't bring down two twos. Bring down 1 2. 2 times 2 times 3 times 5. What is 2 times 2?
4.
4 times 3?
12.
12 times 5?
60.
So your greatest common factor is 60. So if we were to list all of the factors for 180 and 600, if you didn't do the factor tree, you just listed them all, it would take you forever, first of all, right? This method, even though it's kind of, there's a lot going on here, this method is way easier than trying to figure out all the different factors of these big numbers. So then all you do, you would finally figure out that 60, but I have students that are just stubborn and they will literally just try to write out all the factors.
I do that.
Hold on just a second, I just thought of something.
I think I'm one of those people.
I just thought of something.
You do write somewhere.
No. Stop. Okay. Drew is taking her PSAT, and I just noticed her microphone is sitting here, so she's not going to hear either direction. She should have come and gotten it, but oh well. Okay. Any questions so far?
What, on this page, the first one that we did, GCF stands for 12 and 18 is 6.
No.
What are we supposed
We'll have to go back over that later. Okay, stay with us, okay? All right. Make sure you copy all the notes, okay?
I did.
Well, I don't think it said stands for. Okay, so star, if there are no common factors, I thought I heard it drop. The GCF is 1. If there are no common factors, then the GCF is 1. It's right there. It's right underneath your desk.
Oh shit. Isn't one a factor?
It is a factor, so that's what they're saying. If there's no. If there's no, like, prime factors or anything, if there's nothing, if they don't have anything in common, then 1 is it. Okay, so example. Let's say we want to find the greatest common factor of 9 and 16. 9 is 3 times 3, right? Those are prime. What about 16?
4 times 4.
4 times 4. And those are not prime. 2 times 2. And 2 times 2. Okay, so if we look, 9 is 3 times 3. 16 is 2 times 2 times 2 times 2. Do they have any common factors? No. So therefore, the GCF for these two numbers is 1. Any questions? Does everyone have this? Okay. Relatively prime. The sixth graders just did this the other day, he was telling me, and they were freaking out. They're like, what does relatively prime mean? Basically, it's numbers whose GCF is 1. So if they don't have anything in common, then they're considered relatively prime. For example, 14 and 15. If you were to do the factor tree out, their GCF is 1. That would be relatively prime. 20 and 21. They also do not have any common factors but 1. So their GCF is 1. What do y'all notice about these two pairs of numbers that have a GCF of 1?
They're only one more.
One is odd and one is even.
One off.
Yeah, they're one.
They're one off, one's odd, one's even, blah, blah, blah. Guess what? 2 consecutive, that means one right after the other, which is what you are basically all saying. 2 consecutive integers are always relatively prime. It's kind of like a little trick. If they ever give you just 2 numbers like that are side by side, consecutive means one right after the other. An even and odd, but they have to be one right after the other. They're always relatively prime. Any questions?
What is what does consecutive mean again? So I can write it
One right after the other. Say 14 and 15, 20, 21. 16 and 17, 30, 31. 43 and 44. You know, one right after the other. Does that make sense?
Yes.
Okay. All right. Now we're going to get into some hairy stuff.
Yay.
GCF, the greatest common factor, can also be found when variables. What are variables? Letters are involved. So GCF can also be found when variables, which are letters, are involved. Now, my students have realized that there's this shock and awe when it comes to finding the greatest common factor dealing with letters. It looks worse than it is. And in fact, dealing with the letters is actually a little bit easier. Let me show you. Example, let's say 15x cubed y and 21x squared. We're going to find the greatest common factor of those two. Don't freak out because there's letters. It looks scary, but wait until you see this. Now I need y'all to pay attention. Don't just write notes and not look or listen to what I'm talking about. When you're doing this, you're going to do the factor tree of just the numbers. So we're going to do the factor tree of just the numbers. So what two numbers when multiplied give me 15?
3 times 5.
Taylor, I'm recording. 3 is prime and 5 is prime. I'm leaving the letters alone. What two numbers when multiplied give me 21, Joanne?
7 times 3.
7 times 3. And those are prime. Y'all have this down?
Yes.
All right, so down here, I'm going to write 15x cubed y. We're going to list the prime factors in just a second. 21x squared. Now, my numbers, I'm going to put them down least to greatest like I always have been. So 3 times 5, I'm crossing out. And I'm going to do the same with my other one. 3 times 7, cross out. I'll let y'all catch up. You know what you do with the letters? You just list them. How many X's do I have? Michaela, how many X's do I have?
2.
Right here, this one.
Oh, 1.
No.
X's?
Yep. Cecilia, how many X's do I have? 3.
Oh.
See, it's X cubed. So look, X times X times X. 3 X's. And I'm multiplying. Aren't these all being multiplied anyway? How many Y's do I have?
1.
Over here, Michaela, how many X's do I have?
2.
Perfect. And I'm listing those. Any questions so far? Now all I do is circle what I have in common. What do I have in common, Izzy? I have a 3 in common. I have this X in common. And another X. Here's my little arrows. I have 3 times X times X. Multiply it all together. Michael, what 3 times X, what does it give me?
3x to the power of 2.
You are absolutely correct. 3 times X to the power of 2. 3x squared. There's 2 X's, so I write it in exponential form. That's how you deal with letters. That's not too bad, is it? All right. Open up your books. Does everyone have this down? All right, open up your books to page 147. We're doing examples, and I'm only doing a couple. You'll find out. We're going to start with 14. Y'all ready? All right. It says, use prime factorization to find the GCF of each set of numbers. So 14 is 60 and 84. Let's go, let's go, let's go. Oh, look, Cecilia's ready to go. Cecilia, why don't you do 60? 6 times 10. These are not prime, so I keep on going.
6 equals 3 times 10.
And those are prime,
10 equals 5 times
and those are prime. Okay, I'm going to go ahead and write over here 60. Cecilia, how do I list this?
4.
And make sure you cross it out so you don't get messed up. Good. And you put them in order from least to greatest. Good job, Cecilia. Any questions so far? Taylor, what two numbers when multiplied give me 84?
42 and 2.
42 times 2. 2 is prime, but 42 is not. What do I get there?
21 times 2.
21 times 2. 2 is prime, but 21 is not.
7 times 3.
7 times 3, and they're prime. So Taylor, tell me how to list them.
2 times 2 times 3 times 7.
Very good. And I'm crossing them out. Wait till y'all catch up. Any questions so far? Michaela, what are my pairs?
2 and 2.
2.
2, 3 and 3. That's it.
All right. Those are my pairs that they have in common. So I'm going to write 2 down here, another 2, and a 3, and I multiply them all together. What do I get, Joanne? Wake up.
You get 12.
Yes. So 12 is the GCF. Very good. Any questions?
On the first page, why did we circle them separately instead of?
It doesn't matter.
It doesn't matter?
No.
Oh, okay.
Good question.
It's the same thing.
Uh-huh.
And why did we write and not GCF stand?
Well, we'll have to go back over that later. I'm going to
We're
keep
not done
moving.
with notes.
No. All right, 18. Y'all ready? This time there's 3 numbers. I have 12, 18, and 24.
Hey, 18 is
Izzy, what 2 numbers in multiply give me 12? 6 times 2, and 2 is prime. What do I get with 6? What?
3 times. Oh, 2 times 3.
Okay. I think it's a 2 times 2. I don't know. Okay, let's see. Let's write that out. 12. How do I write it out again? Good. In order from least to greatest. Good job. Michael, 18. 6 times 3. 3 is prime, so 6 would be
3 times 2.
good. So list them for me.
2 times 3 times 3.
Very good.
If you were to do 9 times 2, would you get the same numbers?
Yeah.
You would?
You still have the same prime factorization. All right, 24, Wit.
6 times 4.
6 times 4.
And then for 6, 3 times 2. And then for 4, 2 times 2.
Good.
And then 2 times 2 times 2 times 3.
Perfect. Okay, so this one looks a little different because we're dealing with 3 numbers. 12, 18, and 24. Gabby, what do all 3 have in common? And 3. Guys, it doesn't matter if there's a a pair right here, we're dealing with three numbers. So you got to find what they all have in common. Do y'all see that? So they only have a 2 and a 3 in common. So Izzy, what is their GCF?
Wait. 6.
Very good. Their greatest common factor is 6. Any questions about that problem?
What if there was no common factors?
What did we say?
Oh,
Yeah, there you go. Very good. If there's Michaela had a really good question. She goes, "What if we didn't have anything to circle here?" Then our answer would be 1. Greatest common factor would be 1. Good question. Does everyone have this down? All right. Look at number 22. This will probably be the last one we do. Because you've got an example that we did with a number there, so I think you'll be fine. Yeah. All right. 22, we're dealing with letters. A squared times b to the 5th power, and then a cubed times just b. This one, you don't have to do any factor tree. Remember, with letters, you don't have to do that. So we're just going to write them out over here. That's the beauty of these. Now, if I had a number there, we would do it like we did right here. We would do the factor tree of the numbers, work it out, and then do the letters, okay? But in this case, there's no number. So, Michaela, how many A's do I have?
2.
So A times A. How many B's do I have, Joanne?
5 B's.
That's right, times B times B times B times B. That's 4 times B. 1, 2, 3, 4, 5. Okay, let's do the next one. Cecilia, how many A's do I have? So A times A times A, we're just writing them out. And how many B's do I have, Izzy? Times B. Now, Michael, what are my pairs?
A, B.
That's it, right? Is that it? Is that it, Michael?
Yes.
Okay, good. He's correct. So I have A, one A do I take out of there, times another A. So just one of each pair times B. What do I get with?
A to the 2nd power times B.
Perfect. And there's your answer. Any questions? You think you guys got it? You are doing page 147. Numbers 13 through 27 odd. That's 8 problems. No. It's due Monday. You have a quiz on divisibility. On Tuesday, you have a test on Friday. And your IXL is all due Wednesday, a week from today. Any questions? I'll
What's
sh-
the test on Friday?
The chapter
For
that we've been doing.
math?
Not Michaela? Think about
I
that.
know, I'm just trying to make sure, because don't we have a